Hello, good morning. I'm here to discuss selection sorting today. The way the selection sorting works is first you have to find the minimum value within the array of numbers. So we start from the left, like 7. So right now the minimum number is 7. Then we move to the next. Is 7 greater than 8? No, it's not. So for now 7 is still their minimum number, and so on and so forth. So end of the list is 3, and then the lowest number on the array is 3. So we swap out 3 and 7. And then we start again. So right now, since 3 is part of the sorted part of the list, we no longer include it. So right now our minimum number is 8. So is 8 greater than 5? Yes. So our new minimum number is 5. And then we move out. Is 9 greater than 5? Yes. So 5 is still the min. Is 7 greater than 5? Yes. So right now 5 is min. So we swap it out to the sorted part of the array, and we start again until every number in the array is arranged according to the value. So we start with 8. 8 is less than 9. So right now 8 is still the min. 8 is greater than 7. So we swap out 8 and 7. And once more, 9 is greater than 8, so we swap 9 with 8. And that's basically how selection sorting works.
So, after my friend discussed how selection sorting works, here is an example code program of selection sorting here. So, the first line is, this is the given numbers sort. So, after this, we have to input for I in range, then A. This is to traverse through all array elements. And then minimum index equals I. For J in range, I plus 1 then A. If A minimum index is greater than A J, minimum index equals J. So this is to find the minimum element in the remaining unsorted array. So this is the one. A minimum index equals A minimum index AI. This is to swap the found minimum element with the first element. So print sorted array. So this sorted array is the string that will be printed later in the console. For I in range then A, print AI. So this is the code to test if our program is properly working. So I'm gonna run it. So 35789. So our program works properly. That's all. That is how you code selection sorting. Thank you.
So good morning, everyone. So we're gonna talk about first is the bubble sorting algorithm. So as you can see here in my presentation, we're gonna first compare the first two numbers, which is the 2 and 3, and then as we can see, 2 is less than 3, so it is already sorted. So we're gonna proceed to the next set of numbers, which we're gonna compare is 3 and 4. So still the same. The 3 is less than 4, so we're gonna skip that. And then now we're gonna have the 4 and 1. So as you can see, 4 is less than 1. I mean 1 is less than 4. Sorry. And then that's the time we're gonna swap their places. So we're gonna swap their places. And then after that we're gonna go back to the first again. So again, still the same, 2 and 3. And then we're gonna compare 3 and 1, which is 1 is less than 3. So we're gonna swap them like that. And then not gonna proceed to the we're not gonna proceed to the last set of pairs because it is already sorted. So we're gonna go back again to the start, and then it is already 1 is less than 2, so we're gonna swap the numbers. So that is the illustration of what bubble sort is. So we're gonna proceed to the coding. So first of all, we're gonna use the nested loop to solve this problem. So for I in range, 0 is len my list, the length of the list, and then it is equal minus to 1. So in my first example, there is 4 numbers, so we're gonna have minus 1 because so that we're gonna have 3, only 3, because we all know that the last number is already sorted. So next is we're gonna have the inner loop, which we're gonna check if the number is already sorted in the last one. So as you can see, still the same, and it's only have minus 1 for the range. So next is the if my list is j is greater than my list is j plus 1, that's the time we're gonna swap the places of the numbers that we compared to. So my list j plus 1 equals to my list j plus 1, so my list j. After that, we're gonna return the list. So we're gonna have the example here, the list, the unsorted list 2, 4, 6, 8, and 3. So we're gonna have that list gonna be used in the definition bubble sort, and then if you run the code, we'll have the sorted list of it. So that is simply what bubble sort is. That is for me the most easiest sort.
So now let's move to heap sorting. So first we have to sort this tree, this binary tree. So what we're gonna do first is swap 88 with 60. So swap 88 with 60. Now, since 60 is less than both of his children, so we have to swap it with the larger child. So we have to swap it with 85 since 85 is greater than 83. And then, same process, largest, swap 60 with 73. Right here. So now, that's done because 88 is out of the array, so we have so we can't swap that, it's out of the array. So next, back to what we did the first thing, we have to swap the root node with the last node. So we have 48 and 85. So same process, swap with the largest child, 48 and 83. Same process, 48 and 57. So there. So now, it's just repeating the process that we did. We swap with the last node and then we arrange it by its value. So 83 and 6. Now 6 is the root. And we swap it to the largest child. So 6 and 73. And then 6 and 72. There. So now we have to swap 73 with 48 since this is the last node. Swap. There. And then swap again with 72 because this is the largest child of 48. And then 48 swap with 60 because this is the largest child. So swap that with 60. Now it's done. So we have to proceed to 42. So 72 swap with 42 because this is the last node. And then we swap 42 with the largest. So 60 and 42. And then 42 with 48. So these nodes are now out of this array. So now let's move to 57 and 6. 57 and 6. Now let's swap 6 with the largest child, so 48. Like that. And so let's swap 48 with 42. This is the last. And then 42 with 6 because this is out of array. So we swap that too. So now we have the smallest node in the root node. So this is the heap sorting. So now let's move on to our code. Here's the code. We have it prepared for the sake of the video. So first we have to initialize the largest as root. So we have the largest as root index. There we go. And then after that, we see if the left child of root exists and greater than the root. So left child, there it is. If it's greater than the root. So this is how you code it. And then after that, you see if the right child of root exists and is greater than the root. So that is. So in this part, you have if the root needed to be changed, to be swapped. So this is the code for that. Next, we go to the loop, for the heap sort. So we have to. This is to build the max heap where the largest is the root. And then this one is for extracting elements one by one. And the last part is to print the array or the code. So you run the code, keep sorting. So now we have this 8 as starting, and then 12, 35, 42, and 51 being the last node.
Hello, good morning. I'm
Hello, good morning!
here to discuss insertion sorting. The way insertion sorting works is just like how we arrange cards in our hands. So basically, when the numbers are here, the numbers in the array are set up like this. We just pick a number. We look for the lowest number, and then we move it to the furthest to the left. So let's say if the number is 5, we put it here and say if is 5 less than 13, yes. Is 5 less than 11, yes. Is 5 less than 12, yes. So we put 5 to the first number in the list, in the array. Then we go and get another number. If we choose 13, is 13 less than 11? No, so 13 stays in its place. Then we choose 6. Is 6 less than 13? Yes. Is 6 less than 11? Yes. So on and so forth. So 6 is next to 5 now. Then we choose 11. Is 11 less than 12? Yes. So we swap 11 and 12 out. And they are now sorted. That's how insertion sorting works. Now to our code. For insertion sorting, we just create a code that traverses the whole array. First, we create a function that traverses the whole array, and then we create a key. A key is created to become a placeholder for the numbers. So if a number is less than the key or greater than if a number is greater than the key, then they are moved to, one step further from their current position. So like here, This is the key for now. This is the key, and then j equals I minus 1. So from the range minus 1, that's the value of j right now. Then here's our array: 12, 11, 13, 5, and 6. And just like the PowerPoint presentation a while ago, when we run it, it comes out the arranged version, same like the PowerPoint presentation a while ago. It just sorts them in a card-like manner. That's it. That's how insertion sorting works.